We got this problem right here. I will try to make it as easy as possible. Okay. One of the things that I like to do right at the beginning is to make my table, in which I'm gonna write my nodes and my unknowns. What essentially what I want to find out, right? I am given the area of this person. You guys can go ahead and read the problem. I'm gonna dive right into it. My area is 1.7 meters square. Okay, I'm also given emissivity, which is 0.5. No units. Okay, if you guys take a look, there's no units for that. And also the uh, temperature is 32 degrees Celsius. Okay, so temperature in this case is gonna be 32 degrees Celsius. If you guys read the problem, they actually want you guys to find what it would be at 300 kelvins and at 280 kelvins. Therefore, what this is telling me is that I need to convert this degrees Celsius into kelvins. So what I'm gonna do right at the beginning is that I'm going to add 32 plus 273. That way I get my degrees in kelvins, which if you do that, you get 305 kelvins. Okay. Um, so they want you to determine the rate of heat loss, which we already know is going to be negative at the end of the day, right? But I'm not gonna worry about that for now. Um, I do need to determine the rate, which is Q dot, and the formula for radiation is this, right? And temperatures raised to the of the surrounding of the surface raised to the fourth minus the temperature of the surrounding area or environment is raised to the fourth. Okay, so at this point it's just a matter of plug in. That's essentially all I'm doing. All right. So Q dot is going to equal to 0.5 times Stefan's Boltzmann's value, which is 5.67 times 10 raised to the 8th. Now I need to make sure that I include my units, which is watts per meter square times kelvins raised to the fourth, which means that my temperature is going to be raised to the fourth. Area, which in this case is 1.7 meters square. Okay, and also I need to include 305 raised to the fourth minus 300 raised to the fourth. Okay, now I'm gonna have you guys do all of this on the calculator. Essentially multiply 0.5 times 5.67 times 10 to the negative 8 times 1.7 times 305 raised to the fourth minus 300 raised to the fourth. Now I do need to include my unit in here. It's one of the things that I've told you all. It's very important, right? So let me move this just a bit to the side. And let me just rewrite this. Okay. And that is going to be kelvins raised to the fourth minus 300 kelvins raised to the fourth. Okay. And once you do that, this number 305 raised to the fourth essentially becomes some big number, but the most important thing is that you're gonna end up with k raised to the fourth. And actually, let me just redo this. 300 or 305 raised to the fourth is going to be 1220 Kelvin raised to the fourth minus, oh no, that is wrong. That is gonna be some big number, and I was not gonna have enough space in here. But let me see. If I multiply that, yeah, I won't have space to write all of that. But once you multiply this, 305 raised to the fourth times Kelvin's raised to the fourth minus 300 raised to the fourth times Kelvin's raised to the fourth. You essentially have the same variable with the same exponent, so you just subtract them. Okay, that's what you're going to end up doing, subtracting them. So if I was to do that, let me see, maybe I could do that. On my calculator, 1, 2, 3, 4. If you, once you raise this number 305 to the fourth and you subtract from this number 300 raised to the fourth, what you're going to get is going to be a really big number, millions actually. And this is just gonna stay as k to the fourth. Okay, and I'm gonna bring everything else down, and I'm gonna bring this guy over here as well, which is 5.67 times 10 to the negative 8 watts per meter square, k to the fourth times 0.5. Notice I have not multiplied anything except for this. I know this is gonna be a bit tricky, but just as a recap, raise this 305 to the fourth, and also the k, which stands for Kelvin, to the fourth. Okay, and then this 300 kelvins raised to the fourth. So if you do that, you subtract them, you're gonna end up with this number, Kelvin to the fourth. You do all the math, so then the rate of energy transfer is just going to be 26.7 watts, because kelvins cancel out, kelvins to the fourth cancel out, meter square cancel out, so the only units I end up with is just watts. Okay, and that's my final answer. All right, that's all.